This is our fuse box puzzle that I designed. The mechanics are pretty straightforward. You kind of click and drag wires and you can attach them to these top boxes up here. And then you can reset to make the wires go back to their original square. The goal is to connect the necessary wires to the target numbers in such a way that each wire equals the target number. So the solution to this one is 9 plus 17 equals 26, 5 plus 15 plus 12 equals 32, and 16 plus 13 equals 29. Then this win text, some sort of win text will appear and lead to the next phase of the puzzle. In this puzzle, the other player will give you the numbers that correspond to these different colors on their fuse box puzzle. So they will give you the numbers to enter. And once again, some sort of win text will appear. One quick thing to note is that there are some white boxes here, and you don't know which order you need to enter them in, so there will be some number sequencing for both players. And that's the fuse box puzzle.
This is James Flager, and I did the event tracking system. It's a system that keeps track of current checkpoints, past checkpoints, and objectives, and is a centralized place for when multiple checks need to be made for certain events to start or finish. Events could be when a player interacts with an object, reaches a certain point, or a certain time has been reached. The events are able to use this system to check if there's multiple triggers or multiple conditions that need to be met. Here's a small demo that's very simple, where we just have the player, they've reached the A marker now they've reached the D. If they come over to C, nothing's really happened. Now they've reached B. Now this starts the C quest, where then now they've reached C. The way I'm expanding this is I'm going to move it into an object-oriented approach. And so there's just a parent class of event that they all inherit from. And the way the events know who they are is with an event ID system. And with that event ID, they're able to grab their associated text and activate their associated scripts with that event. Thank you.
All right, so this is our black room prototype, which consists of a maze. And what happens is as the player moves down this corridor, which will be finalized in our final version, have all the graphics, they'll be coming from the left, move towards the right, and they'll hit a trigger that triggers the camera to shake and a dark fog to envelop the character as they enter the maze. And this is where a second player will be guiding them through this maze based on the map that you're able to see at the bottom left right now. Only the other player would have access to this map's image and would have to guide this person through. And if we go back down the hallway to leave the hallway, the lights will turn back on and this dark fog will go away. However, if they once again try to enter the hallway or move towards this area, it should slowly fog down once again. So that way the player can't see at all inside of the maze. Once they exit through the maze all the way on the other side, which I'll go ahead and I'll just move, if I can figure that out. There we go. This is our maze as it is. It's quite big. There's nothing added right now, but if they make it all the way out to the other side over here, then the dark fog will also lift up and they'll be able to progress through the game. What we're thinking of adding though for final versions is having little parts on the map in our maze that are little symbols on the floor to help the player not get lost or recover when they accidentally go down a different path. This prototype also has the ability to show off the movement system that we've created. Since our game is in space, we have a no-gravity movement system. So when the player presses a button, they'll be moving, or they'll get some forward propulsion in that direction. And the only way they can really stop is if they come across a wall. Right now our character doesn't turn, because that's the movement system we plan to implement at the end, as we'll have 4 directional facing sprites for movement. The other thing that we implemented in this prototype is the camera following system. To give it a little bit of a different feel than a strictly grabbing camera that follows the character, we have the camera track a little bit behind to also give a sense of which direction the player is moving, so that way it's not always just tagged on. But in this prototype, the only way we got the camera shaking to work is if it's currently attached to the player, but that also brings a little bit more attention to the shaking event. But once it's over, it'll go back to the normal camera system that we have implemented.